Hello, everyone. I'm Cheri Daughter, and I'm here with jonely and we are here at Tier 1 Interventions, and we are so glad to have you here today. Jonely and I are going to talk to you a little bit about this thing called a pizza problem.
Absolutely. We have a good bit of content today that we're going to roll out to you. We're going to lay some foundation though and define what is tier 1 intervention. We want every kid, regardless of ability, deficit, struggle, we want them to experience whole classroom, regular general instruction, which we're going to call tier 1. Tier 1 is whole classroom, regular classroom. In math and writing, tier 1 was not where it should be. Mathematically, all we need are 12 anchor problems and tasks. That's it. This is how simple it can be. Tier 1 math intervention. Every standard from preschool through high school, every standard boils down to 12 what I call reference tasks. Reference tasks are math problems, situations, tasks, experiences, exercises that are named, that are frequently given to students at every grade level and frequently throughout one grade level. So the 12 tasks are exactly the same, no matter the grade level, no matter the age level, no matter the ability level. And they are differentiated enough, inclusive enough, accessible enough that any one task will meet the needs of all students in the same classroom at the same time. And as a reference task, we bring these problems up every month or every 3 weeks or at a frequency level so that kids get more interaction with the same task again and again. So that when we're teaching our content, when we're teaching our textbook, when we're teaching regular math lessons, we can refer to, hence the name reference, these reference tasks to make connections. And we use these reference tasks as our math intervention tool. With all students at all grade levels know and have experienced each of these 12 tasks at some point in their preschool through high school career, I can then use these reference tasks at the tier 2 and tier 3 level to provide intervention. You don't need to worry about what they are, but bottom line, mathematics comes down to these 12 tasks, all preschool through high school mathematics. And they are pizza problem, 120 chart, paper folding, making rectangles, quick dots, locker problem, Jesse and Kay, geoboard, candy problem, paint problem, staircase, and function machine. I would use these reference tasks as intervention and extension to meet all levels of my students within the regular classroom, within tier 1, and all students would be able to get the math needs that they needed through each of these tasks. What we're going to do is only focus on one of these reference tasks, and that is the pizza problem. The pizza problem is a company makes square pizzas. That's it. And that's the beauty of a reference task. It can be introduced in less than like 10 seconds. The pizza problem situation is a pizza company makes square pizzas. That's it. And what we're going to do now is we are going to show you how the pizza problem is delivered and rolled out in multiple frequencies and interactions. We know that students, to achieve high, need more interactions over time with the same thing. Our gifted students, kids that are truly gifted, they might need 1 to 2 interactions before they know it forever. That is exactly what math reference tasks do. And we're going to show you that now. So here we go. Pizza problem. Let me explain interactions. In the first month of school, I talk about how that's the first time I expose students to each of the reference tasks. Now, let's say you're listening to this and it's February and you're like, I guess I have to wait till next year. No, math in a month can happen at any time during the school year. Don't wait till the beginning of the year to have interaction one. As a matter of fact, some of us teachers will do interaction one in April or May because testing is over. We're ready to engage kids and just keep them busy for the last month of school. Interaction one can happen at any time of the year. Don't misunderstand that. Interaction one means I'm going to introduce whatever reference task it is. Today, it's the pizza problem. I'm going to show you how I facilitate the first interaction. Many teachers say, look, I have this pacing guide, this textbook, I have all this curriculum I need to cover. Jonely, I don't have time for this. Great. Each of your interactions can be 6 minutes, and then you can go on to whatever you normally teach. If you don't have time, I'm asking you to make time 6 minutes once a week. That's it. These things can happen in a very small amount of time. Other people are like, look, my resources that I'm using, they're not working. My kids aren't learning. Can I do this for my entire class period? Absolutely. If that's the case, you might do more than one interaction at a time. But I want to caution you, as you give kids the reference task a second time or a third time or a fourth time, it is essential based on cognitive science that there is space between those interactions. There's time between those interactions. Cognitive science calls it spaced practice, which means repetition is essential, but we need out of context lessons that don't have to do with the pizza problem in between the frequency of the pizza problem. So between interaction one and interaction two, there might be 4 days that go by. There might be 4 weeks. There might be 2 months. But it's essential that we practice what cognitive science calls spaced practice. So when we introduce the pizza problem, we're only going to go so far. Then we're going to stop and move on to our lesson of the day that is totally unrelated. These are small bursts of out of context math experiences. In cognitive science, we call that interleaving. Interleaving is not my term, it's a cognitive science term. And what that means is, in order for the brain to learn and remember and create long-term learning is through interleaving, out of context bursts of content that happen in between other non-related content. Through spaced practice and interleaving, reference tasks become more powerful. I had a teacher one time and they're like, oh my gosh, I did pizza problem for 6 days in a row and it was amazing and my kids loved it. I'm like, okay, that's great. However, that's only really one interaction. You're not getting the power and the benefit of the reference task because you did the same thing for 6 days. There was no out of context bursts and there was no space in between. So you couldn't practice interleaving and spaced practice. So you've lost the opportunity to increase the memory and retention of that. Because really that 6 days in a row of the same thing is one interaction. The goal is to introduce pizza problem once in August, once in September, once in October, once in November, or once a week, or once every 8 weeks, or once every other month. Once every other month. You've got to have space in between. So interaction one, a pizza company makes square pizzas. That's it. Now, what do I do with my kids? I say my favorite 3 words, tell me about. Tell me about the pizza company. And then I give kids opportunity to process. Now, cheri and I would never talk at kids for the amount of time that we've just been talking at you. Wouldn't happen in a classroom without an intervention brain break. At this point, with all of you, you might have been like, oh my gosh, I am totally checked out. What you need is a process time. The math instructional facilitation that's going to re-engage and redirect you is for me to ask you right now to put in the chat your thoughts about this pizza situation. That's going to re-trigger the engagement and focus. A pizza company makes square pizzas. That's it. Just tell me your perspective. The point of this is to re-engage your mind, to redirect you, to refocus you. And for kids, it's telling them, I care about what you think. I care about your perspective. I do not jump right into mathematics with solving and answer getting, because solving and answer getting separates and polarizes kids. I have kids who can, I have kids who can't, and everybody else is in the middle. Which is why we need to have these conversations about these strategic interventions, not at the tier 2 or tier 3 level. These are things that 100% of our kids need to experience. That's it. It's as easy as that. If I'm telling them, they hear it. If they're telling me, they learn it. They have to tell me. Through this, I can assess what they're thinking. So it's an assessment for me as a teacher, but it also allows students to feel like they belong because I care about what they're thinking. And this is what Cheri and I call the tell me more method. If we ended this training right now and you walked away with only tell me about, tell me more, and practice that daily in your regular math classroom, that in and of itself would increase memory, retention, and motivation, focus, and engagement for our students. Now, there's more to it. It's got a lot of components. This strategy right here that doesn't take a lot of planning time is the number one strategy to do multiple things for our students. I'm asking them what they think about the pizza problem company. I could ask some additional questions. Sometimes what I'll ask in the first interaction with kids is, what are squares? Here's what's important in the first interaction of any reference tasks. I'm not confirming or denying their answers. If they say to me, squares have 5 sides, part of reference tasks means that I, as a teacher, have to be diligent on how I respond. How do I respond to a wrong answer? And how do I respond to a correct answer? The answer to that is the same way. If a student says, squares have 5 sides, I'll say, tell me more about that. Do you see how we're going right back to that strategy? If I tell them my opinion, they hear it, but they don't learn it. I always go back to tell me more about that. Now, in the meantime, some other student's going to pipe in and be like, don't have 5 sides, they have 4 sides. How am I going to respond as a teacher? Tell me more about that. The best strategy we could use as a facilitation technique, not just for tier 1, but for a regular classroom teacher, is many times in mathematics, we want to practice not confirming or denying student responses. That practice alone will increase thinking, reasoning, and sense making, will increase and tap into the natural creativity that Cheri was talking about. Our ADHD students thrive on creativity, and typical traditional math classrooms hinder creativity. So by me not responding, confirming or denying student accuracies or inaccuracies, by me responding the same way to correct and incorrect answers or thoughts helps the ADHD student thrive. Another question I can ask, how are squares and rectangles different? How are squares and rectangles the same? And if that's all I do on interaction 1, that's it. 6 minutes, 12 minutes, that's it. That's pizza problem interaction 1. There was nothing taught. There was no teacher telling or instruction. It was just gaining student perspective, getting them excited, enriching creativity, and generating curiosity. Because if I don't confirm or deny, and I linger all of their responses and say, okay, let's go on to our lesson of the day. Go ahead and take out your book and turn to page 384. They're going to be like, lingering questions and problems are also the key of increasing memory and retention of content. Because once I confirm or deny a student's thought, everybody's thinking and reasoning stops. At times, I want to leave these concepts lingering.
Teachers ask us every day how to implement these reference tasks, and occupational therapists question how to integrate themselves into the regular education classroom. You have heard the science behind the tasks over the past few months, but until now, we have not implemented these tasks for you. The next segment is sponsored by Disability Labs, where we provide teachers and therapists with the tools to implement interactive, interdisciplinary interventions through our professional development programs for the general education classroom. Teachers learn from OTs, OTs learn from teachers. Inside the community, we offer free and paid training that supports students' writing and math skills so they can become the adults they were meant to be. The next upcoming event is on July 12th, and it will run for 4 consecutive Fridays. Your instructor is Teresa Rodriguez, a school-based occupational therapist from Massachusetts. She is also a dysgraphia specialist using the Daughter Dysgraphia method. She will be doing a book study on handwriting brain-body disconnect. The cost for that program is $47. Go into disabilitylabs.com under the calendar and sign up today. The next segment is called Hear Me Teach. Jonily takes you inside her classroom and lets you listen to her while she implements the pizza problem. This episode is in a kindergarten classroom, and please note that all appropriate releases are on file at the school. Her teaching session lasts about 30 minutes. Sit back with your cup of coffee or listen while you're driving and listen to Hear Me Teach by Jonily, The Pizza Problem, Interaction 1, to a group of kindergarten students.
We are back here with kindergarten, and today we are not going to go back to Purple X, but we will eventually. We are not going to go back to our monkeys, but we will soon. We're going to do a new task today called the pizza problem.
Pizza problem?
I don't have pizza for you.
No.
Disappointment.
To eat pizza.
Here's the situation. This pizza company only makes square pizzas. So we're going to make this very mathematical. So I know you've seen pizzas that are round and rectangle and cut different ways. So the way that we're going to define this math task is that this company is only going to make pizzas that are square. So we're going to practice with squares today. What shape are we going to make today? Square. Somebody raise your hand and tell me about a square. Tell me about a square. Start us off.
It's flat.
Oh, I love it. And we're going to use our flat pieces. When we say flat, I'm going to call that 2D, two-dimensional. Say that.
2D, two-dimensional.
Perfect. Because it's going to be a certain amount, it's going to be flat on your desk, and it's going to be a certain amount tall and a certain amount long. We're going to talk about how tall and how long our squares are. Tell me something else about squares.
They have points.
Oh, they have points, like the corners. And I'm going to use a math word, vertices. Say vertices. Vertices. How many points do they have? Tell me on 3. 1, 2, 3.
4.
Got it. I knew we were going to do okay with that. All right. What else can you tell me about squares?
They have 4 sides.
Fantastic. Did you hear that? Say it again.
It has 4 sides.
What is special about the 4 sides that squares have? Yes.
They're all equal.
You know what? I love how he said that. Say it again.
They're equal.
Equal. Sometimes some of the older kids say they're all even. But that's not the right word to use. Even means something different. I love that you use that word. Everybody say equal.
Equal.
Raise your hand to tell me what equal means. What's equal mean?
It means like 2 sides are the both same long.
Both same long. Oh my gosh. Your words are beautiful. I'm going to give you another new word today. Another word for equal and the same. Congruent. Say that.
Congruent.
Okay, so what are our new words for today? Our new words for today. What's congruent? What else?
2D.
2D, two-dimensional. What are those corners called?
Point.
Vertices. Say vertices.
Vertices.
Yes. Oh, yes. Go ahead. All right. So what shapes are we going to make today?
Square.
Okay, perfect. Okay, now, here's what you're going to get. You're going to get your pieces again. You've used your pieces a lot. We used those pieces to pretend they were monkeys, and we've made rectangles with them before. You're going to use your pieces. What shape are you going to make?
Square.
Okay. Then what you're going to do is you're going to draw whatever squares you make. So you're going to look at how tall and how long, and that's how many boxes you're going to use on here. This is going to be the tricky part. You're going to build squares. It's going to be great. You're not going to trace what you build because the squares you build with are bigger than the squares on here. One square is one square. One square equals one square. So we're going to try to model, we're going to try to show on here the size of the squares that you're building. Okay? That's a lot of yakety yak for Miss Zupanzik, but what we're going to do now is we're going to get you your materials and raise your hand to tell me what are you going to do. Let's hear from your words. What are you going to do when you get your materials? What are you going to do when you get your materials? Yes. Well, I already gave you the instructions, so what are you going to do first? I know, but that is such a good answer. Yes.
Make the square.
Make the squares, and what else? Yes. Yeah.
Measure the squares.
Well, technically, yes. And then what? Yes.
Draw it on there.
Very good. Okay, here we go. We're going to get you your paper. First things first, put your name on the paper when you get it. Put your name on this paper.
I got all of them out.
Yeah. Put your name on this. Put your name on this.
Stephen, you need to turn around. This is not how you sit here.
Put your name on this. Put your name on this. Friends, you're each going to get a paper. You're going to put your name on that. Go ahead and put your name on this paper.
Are we gonna do it on the back?
What do you think? Sure.
I
You guys are great.
Are you gonna take them out?
Oh, whatever you think you need. I love that question. Great question.
What?
You're going to build your square first with the block, the little square block things you have. Then you're going to count how many you have. One.
Love
Down,
it.
and that's how many squares you're going to use on the paper to create your square on the paper.
Perfect. And hear me in 6, 5, 4, 3, 2, 1. Now that we are situated, what I like to do is I like to give you a lot of directions at once. Then I like to give you your materials, and then I like to recap. So now that you have your materials, I want you to follow these directions. Put your pieces on your desk surface and put your name on your paper. Your pieces are not going to go on top of your paper today. So push your pieces off your paper. And what are you going to do with your pieces? Tell me. What are you going to do with your pieces? Tell me. What are you going to do with your pieces? What are you making? Tell me.
Make a square.
Not on top of your paper, beside your paper. So everybody make a square with your pieces. Go. Make a square with your pieces.
I don't know how to do it. Okay, after we're done.
You can't make your squares on your paper. You have to make your squares over here. Good.
One of these squares.
I don't know how to do this.
Make a square. Make a square.
Okay.
All right. How do you know this is a square? Look at this. Look at this that we think might be a square. How many blocks long is it? How many blocks long is this?
Draw it more here that way.
3.
3. How many blocks tall is it?
3.
Is 3 the same as 3? Yes, it is. 3 is the same as 3, so that does make a square. 3 and 3 are the same number, and that's what makes a square. Oh, but let's check this one. How many blocks long is yours?
4.
How many blocks tall is it?
4.
Is 4 the same as 4?
Yeah.
Yes, it is. So this one has a square too. Good. Oh, let's check this. How many blocks long is your shape? 3. How many blocks tall is it?
3.
Count them. How many blocks tall?
1, 2, 3.
Is 3 the same as 3? Are they equal? They sure are. That's how you know it's a square. Now you can draw your square on your paper, but it can only have the same number of pieces that the square is here.
Okay, so one of these equals 1.
You've got a big square pizza.
So now you get to do
How many pieces long is your pizza?
5.
How many pieces tall?
5.
Is 5 the same as 5?
Yeah.
That's how we know it's a square. So on your paper, you're going to draw your square pizza, but it has to have the same number of pieces as your square. Oh, fix that. Your pencil moved it. Now, if I ordered a pizza and it had all these middle pieces missing, I wouldn't be very happy. So make sure your pizzas are filled in the middle. Make sure your pizzas are filled in the middle. Oh my gosh, I love how you modeled that. That is really fantastic. Now make a different size pizza. Make a different size pizza. Ooh, love this one. Love this one. How many pieces long is your pizza?
4.
4. How many pieces tall is your pizza?
2.
Oh, let's count again.
3.
3. Is 4 the same as 3? Are they the same number? No, they sure are not. So it's not a square. In a square, it has to be the same pieces long and the same pieces tall.
Yeah, you can shade it in, circle.
Oh my goodness, look at this. Let's look at your square pizza. How many pieces tall is your pizza?
4.
How many pieces long is it?
4.
Is 4 the same as 4? Are they equal? They sure are. That's how you know it's a square pizza, so you're good. Now you want to model this. Let me ask you this question though. How many pieces of pizza are in your square? Let's count all the pieces. And then on your paper, that's how many you need to box in. Let's look at yours. Oh, yep. How many pieces? How many pieces long? 4. Wait, it's 4 pieces long. How many pieces tall?
1, 2, 3, 4.
Oh,
5.
5. Is 4 the same as 5? No, so we don't have a square yet. So make an adjustment and see if you can make a square. All right? Now, how many pieces of pizza are in your square pizza here? How many pieces of pizza are there?
9.
9. On your paper, you need to only show 9 of these squares for that pizza. So the number of pieces in your pizza, you need to show on your paper. Do you have a square here? How many pieces tall is it?
5.
How many pieces long?
5.
Is 5 the same as 5? It sure is. You have a square pizza. How many pieces are in your pizza? Figure that out because you have to show me this pizza on your grid paper that you made. Let's take a look. How many pieces tall is your pizza? 3. How many pieces long? 2. Is 3 the same as 2? No. So we don't yet have a square, but you are close. Don't erase this because this is beautiful. How could you add on to this to make a square? Good. Make me a bigger square pizza and do your drawing. I love it. Here's what we're going to do because you are ambitious. That is a very good thing. How many pieces tall is your pizza right now? How many pieces tall? 6. Now, if you have a square, how many pieces long does it have to be if it's a square?
4.
Well, is 4 the same as 6? No. What number is the same as 6?
6.
So I want you to make me a square pizza that's a 6 by 6. I want you to draw it here and tell me how many pieces of pizza there are. You got it?
So we do have to draw.
I want you to make a 6 by 6, 6 tall, 6 long. Draw it here and tell me how many pieces there are. Ooh. We're going to pretend that all of these have blocks inside, okay? Because we don't want to order a pizza and have all these pieces missing. So you're going to actually shade in all those. But let's make sure we have a square. How many pieces tall is your shape?
7.
Let's try again. Ready?
2, 3, 4, 5, 6.
6. How many pieces long is your square?
1, 2, 3, 4, 5.
Count them again.
1, 2, 3, 4, 5.
So your shape is 6 pieces tall and 6 pieces long. Is 6 the same as 6? Are those two numbers equal and the same? Bless you.
Yeah.
They sure are. So you know you have a square. Shade those in and then write the number of pieces in your square. Write the number of pieces of pizza that you have. Hello, I love this. Is a great model of this. Beautiful. Let's check your shape. How many pieces of pizza long is your shape?
4.
4. How many pieces tall is it?
7.
Is 4 the same as 7? So we don't have a square, but don't erase this. Don't erase this because this is a rectangle pizza, a 4 by 7, and I love it. And we could count how many pieces. But change this so that it's a square. Make me a bigger square and draw it. Awesome. Back with me in 5, 3, 1. You all are fantastic. So let's regroup for a moment. We are discovering well. See, I like you guys to just try to figure things out, and this is beautiful. You're making square pizzas. You're showing how many pieces in your square pizzas on your grid paper. Once you make one, then you're going to make a different size. And then you're going to make a different size. And then you're going to make a different size.
4, 5, 6, 7.
But what shapes do they have to be?
Squares.
Very good. I want you to keep going. And I want you to draw as many squares as you can. Go ahead. Keep working.
I don't think I can.
How do you know that's a square?
Because it has 4. Is this
It has 4 sides. How many pieces tall is your square pizza?
Like 5.
5. How many pieces long is it?
5.
Is 5 the same as 5?
Yeah.
It sure is. And you got it right there modeled, and I love it. How many pieces of pizza is in that 5 by 5 pizza? Figure that out and write it down. Where's your square? Build your square for me. Good. Check how. I want you to count how many pieces there are in there. Write it down. Good. You drew that. Now make me a bigger square. Check that it's a square, see how long, see how tall, and then draw it over here. Keep going, make another square. Love it. Make me a bigger square. Good. How many pieces long is your pizza? 2. How many pieces tall is it?
6.
Are those numbers the same?
Yeah.
Is 2 the same as 7?
No.
No, so you got to rework this because it has to be the same number of pieces long and the same tall. Love it. Model this right there. Good. You are going to draw this right here. However many squares is what you're going to mark over here. Good work. Did you get me a square? Good. Okay, here we go. How many pieces tall is your pizza? 4. How many pieces long is it? Oh, let's count again. Is 4 the same as 6?
She's doing it.
So it's not a square. Readjust this, and it has to be the same pieces tall and the same pieces long. Okay? Loving it. I love this. This is really great. Did you make me a square? Make me a different size square and draw it. Make me a different size square and draw it. Good. Good. Now model this one over here. How many pieces of pizza do you have in your square pizza?
3 and 3.
Let's check. Let's count all of them.
1, 2, 3. 1, 2, 3. 1, 2, 3.
Oh, how much are 3 3s? That's a tricky one. Count all those pieces and then show that many pieces over here. Did you get a square, my girl? You're closer. I'm loving this. I'm loving this. Here's my question. What are all the number of pizzas that make squares? Let me ask it a different way. I want you to figure out how many pieces are in this pizza, and this pizza. There are certain numbers that always make squares. See if you can write those down.
So 25 pieces.
Write that down. Do you have one with 25 pieces? Check and see if you do, because she does. She's got. Now, what are all the numbers of pieces that I can make with square pizzas? I can make a square pizza with 25 pieces. Can I make a square pizza with 12 pieces?
Yeah.
Try it. Use 12 pieces and make a square. Use 12 pieces.
I did 3 and 3.
And is 3 and 3 the same?
Yes.
Yes, they are. How many pieces of pizza are in this pizza then?
I have 37. 1, 2, 3. That looks like Roblox. 4, 5, 6, 7, 8, 9.
9 makes it, write that number 9 because they're trying to figure out what numbers make square pizzas. So if I order square pizzas from the restaurant, I want to know how many pieces I'm going to get in my pizzas. Okay? Good work, kid. Now make me a bigger one. Make a bigger one. This side of the room, especially my back row here, I want you to count how many pieces of pizza are in each of your square pizzas. So I want you to count how many pieces there are. Because what we're trying to figure out is, when we make these square pizzas, how many pieces do we get in each pizza? So check your first pizza there. How many pieces are in your first pizza there? Count them for me. Show me how you count them.
1, 2, 3, 4, 5, 6, 7, 8, 9.
How many is that? I want you to do the same thing. Count how many pieces of pizza are in this square pizza.
8.
So write that down. You could write it on top or beside. You sure could.
This one's 16, and I'm going to write this one down.
Okay. Write that down so you don't forget it. Because what we're trying to figure out over there is, when we order square pizzas, how many pieces are we going to get? So if we order a 3 tall and 3 long pizza, how many pieces will I get? And if I order a 2 tall and 2, if I order a 4 tall and a 4 long, how many pieces will I get?
You can't make a square with 12. It's a rectangle.
You what?
You can't make a square with 12
You can't? Why not?
because there's 2 and 3.
Now this is interesting. She's saying that I cannot order a square pizza with 12 pieces. What do you think about that?
Because there's 3 on one side and 2 on the top.
Huh. All right, friends, come on with me in 6, 5, 4, 3, 2. I love how you are working today. Really love it. Here's a question I'm going to leave you with. If I call this pizza company and I order one of their square pizzas, could I ever get a pizza that has 12 pieces?
Yes. No.
I don't know. Hear me in 3, 2, good. Put all your pieces in your cup. Put your cup on the top of your desk. Put your name on your paper. And we'll be ready in 2 minutes.
Join us in 2 weeks.
minutes.
And Jonna we will do a session, Hear Me Teach the 120 chart. Join us in